This is Morten from Inkish. Today we are in a fascinating facility. We will introduce that in a moment, but before we do that, let me introduce Jason. Jason?
Hello.
Good to see you.
Nice to meet you. Good to see you.
To me, you sound American. Are you American?
I am an American. I'm from Oregon.
From Oregon. Okay,
Yep.
That's one of the northern states, right?
Sure is. West Coast,
West
just
Coast.
above California.
Okay, fantastic.
Yep.
I was just wondering because you're American, but we're in Germany. Why are you here?
Great question. I am here with our strategic manufacturing partner, Koning & Bauer, to talk today about the T700. It's our newest press in the packaging application space, and excited to tell you a little bit about it.
And I mean, when you stand in front of the machine, you can only be excited about it because it's really fantastic, right?
It's very fantastic.
Yeah,
It's
huge.
It's a dream. It's big.
Yeah.
It's productive. It's the bringing together of all of HP's page-wide inkjet printing technology and Koning & Bauer's paper handling to make a great product we're excited about.
We're going to make a walkthrough of the machine, but before we do that, your background is engineer, so I guess that you have been involved with this project for some time, right?
Yeah, so I'm a principal system architect for page-wide industrial, and I started working with Koning & Bauer on packaging presses in 2014 on our T1100 series. So it's been an 11-year journey with them.
And I mean, as an engineer, you probably know pretty much every bolt on the machine, right?
I'm pretty familiar with this product and with our systems, right? The paper handling, the dryers, the printing technology. Yep.
When you look at a machine like this, and as you mentioned, working with Koning & Bauer as a partner on this project, what benefits does it give HP and hopefully also Koning & Bauer when you have a machine that is combined by two giants in the market?
Yeah. So I don't know that we could have done this without each other, right? Koning & Bauer brings all their expertise in paper handling, right? We're talking about 1.7 meter wide width. We're going to go 1,000 feet per minute, which is 300 meters a minute. So at that size and at that speed, you really do need someone with expertise like Koning & Bauer.
And you forgot one thing: it's a water-based printing engine.
It is.
Right?
It's water-based thermal inkjet,
Yeah.
which is what HP brings to the table, right? Our job is to get the dots onto the page, and Koning & Bauer's job is to get the page there for it. So this collaboration has been 11 years in the making, and we think we've brought a really strong product to the market.
As an American, how is it working with the Germans? Is it fun, or is it a lot of differences?
There's some differences, but it's very fun, right? They're great hosts. They welcome us into their facility. This is my third trip in 3 months, so it's been a very good partnership.
We're going to talk to your colleague a little bit later about the machine in the market and for who it is for. So, but generally speaking, it is about the lamination market or the laminator market. It is a machine that is very fast. It's a water-based machine. So why don't we just go through it?
Perfect.
Okay, great.
Perfect.
So let's start. because we have deliberately decided not to talk so much about the unwinder, because you can basically choose any solution you want, right?
Yeah, most of our customers are going with splicers, and they partner with Koning & Bauer to do those. In this development environment, we just have a single station reel stand, which is more than enough to get us printing, but it's not what we would expect customers to put in. So we're going to start today talking about the pre-coater.
Yeah, let's do that, because everybody that is have been interested in any kind of inkjet print knows that substrates and water-based, it can be a challenge.
Right, so we have developed a fluid that we call a priming agent that's designed to optimize print quality and durability on a wide range of substrates, right? The clay-coated material standard in this space can be hard to print on with water-based inks. But since we've developed the primer and the inks together, we have a solution that works very robustly.
So what happens here? Basically, the paper comes in from the unwinder?
Paper comes in from the unwinder, and we are using an Analox flood coater, very common in the printing world, to apply our primer fluid.
And that primer fluid, that is the one that you spoke about that you have developed together
Correct.
to meet the criteria of the highest possible print quality.
Highest possible print quality, durability to meet the market demands, and to address the wide range of paper quality, right? The lamination space is focused on high quality packaging, but paper's getting expensive. And so customers are always wanting to use a wider range of paper, and the primer really enables us to cover that broad set of media confidently.
I was also thinking that it's super great to have it, because basically that also enables that you have control of what is actually printed on, because if you have too many different substrates, you cannot know what to expect, right?
Correct.
Yeah.
Correct.
So when we follow the paper path from here, then it goes up there. Right?
So it's going to go up, and we're going to go through a set of dryers. Yeah. These are near infrared dryers, yeah. Pretty standard. Same technology that's on our T1100 series. So being able to use that market experience and bring it into this new segment was really part of what made this product possible.
And as you mentioned, your work on the 11 series and now also with the 7 series, I mean, is there a lot of things that you could take off, let's say, what you learned from the 11 series and bring it on board here?
Yeah, absolutely. So we kind of joke that this is the little brother of the 11 series, but it's also, 8 years in the market now. So there's some things that we've learned in the 11 that we've chosen to change and address here. One of those is the paper handling system, so which we can show you a little bit more about that later.
Fantastic. Yeah. So let's move on, because
so we've dried our primer, and so now we are ready to start printing on it. And we're going to climb up this arch and follow the paper through the print zone.
Can't wait.
We're going to come up on the print arch.
Yeah, I mean, that has become like an icon for HP, right?
It is. It's a really optimal design for controlling the paper at the speeds and putting down the ink on top of it.
Before you open it, because I just want to compliment, because I think that's part of also HP. You have a lot of things that can be managed and serviced by the operators themselves, right?
Correct,
right. And what you want to show us right now is how easy it is to replace a printhead, right?
How easy it is to replace a printhead, and we can tell you a little bit more about the printhead technology that's in this press.
Because that's pretty new, right?
It's very new.
Okay.
Yeah.
Let's go. Let's see. Yeah. So you just grab the handle.
So I'm just opening up the access panel, and we see our 2 print bars. So on this press, we have black, cyan, magenta, yellow, orange, and violet. And in order to deliver the quality at the speed that the market demands, we've chosen to have 2 print bars per color. This gives us about 8x nozzle redundancy and lets us achieve full density printing at the full rated press speed, 300 meters a minute.
When you mention, for example, the colors, does that mean that you can configure it? If it's, let's say there's a customer that has special needs, can you do that, or is that just about replacing the inks, or how does that work?
No, it's a standard 6 ink.
So it is
set,
always 6 colors.
Always 6 colors.
But that's good to know, because I'm just wanted to. So with the 6 colors, you of course achieve an extended color gamut. That's how you do it, right?
Yep. The orange and violet help us in both the reds and the blues, which are pretty critical to brand colors, which is a lot of this space, right? Yeah.
And then you have all these, I mean, this is a print bar.
Print bar.
And then you have people can probably see that you have K plus 16, K plus 14, and so forth. So that is the print heads, right?
Correct. On this press, we have 16 print heads per bar. On our T1100, there's 26.
Really?
And on the Advantage 2200, there's 5. Right? So it's a real scalable technology that we are leveraging all across this printing space.
And we're going to take one out in a second, but you said this is a 5th generation, right?
This is the 5th generation of thermal inkjet printhead. Yep. And what the 5th generation brings is full system recirculation. So the ink is always flowing from the ink delivery system through filters, through degasses, into the printhead, and through every single nozzle. So that flow helps us with nozzle health. It helps us with startup, it helps us with drying out, and it brings better print quality through improved uniformity across the width of the printhead.
And for those who watch this film that doesn't know about it, I think that one of the things I really like also about the HP technology, you don't need to clean the printheads after every run. So basically you are way faster ready for the next job.
That's our goal, right?
Yeah,
printhead cleaning is kind of integrated in the machine, and in this space, we really just are doing wipes to get any any ink that's accumulated during the run.
And having this circularity of the inks, as you mentioned, is that something that is like, is that something that people will be able to see, or is it more about the lifespan of a printhead?
So it has brought improved life, fewer interventions, and improved print quality. So it's not obvious that the ink is recirculating as we're standing here, right? But that flow is obvious in the operation of the press and in the quality that we get out the other end.
Let's see it.
Let's see it.
Yeah. Oh, that was easy, right? I mean, you just take that to the side.
Open it up, pull the latch, and I'm gonna pull the print head right out of the press.
And isn't it amazing that such tiny little printhead is able to do all the things, right?
Yeah. Yeah, so this is the same form factor that's in all of our products. What's new is the silicon in the printing on the printhead, right? To enable us to get the flow through the firing chamber. We still have the 2400 nozzles per inch, right? We still have the 5 die that all of our modules have. We've just brought new technology into the silicon.
And it's funny when you hold that, you said that, okay, we have a print bar with 16, right? And when you open them with 16, you have like 5, zones of where it inks the dots, right?
Yep.
It's pretty amazing that it's at all possible, right?
I agree with you. When I first joined HP, they said, we're gonna take this little nozzle that's on your printer at your home, and we're gonna turn it into this, and I was a little skeptical.
You didn't believe it, right?
But,
so, I mean, you told me just.
But we have over 400 presses in the market now, all leveraging this same fundamental technology.
Yeah. And you said, I mean, with the 5th generation, that's even on the 11 series, so it's not even new, it's proven technology.
Proven technologies. 5 presses installed worldwide on the T1100 with this technology, and then the T7 will bring it next.
When you go out and visit the 1100 customers, right? Must make you so proud of seeing what you have been working on for so many years, right?
It's pretty exciting. What's really cool is our customers who had the 4th generation and now have the 5th generation, and to see the improvements in startup, reliability, and efficiency, that's what's cool. Yeah.
Is it as easy to put it in again as it was to take it out?
It is. So, we're just going to put this one back in, but perhaps you'd have a new print head.
Yep.
And you just...
And that basically allows an operator, let's say that there's either a visible fault in the print, or there's some kind of software that we will see that on the camera's inspection, but you will basically get help to saying that, black K8, that needs to be replaced, or you need to do something about that, right?
Yeah. So the press will alert you with print quality issues, and the operator can choose to replace a print head. Sometimes our print heads do wear out. They are...
It happens.
They're
working hard,
but
right? Yeah.
when they're that easy to replace, the press tells you which one needs to go, make the swap, and close the door, and we're back to running.
And I would say also one thing that is a great advantage for a customer is that since HP has so many presses in market that basically uses the same technology, you have a scale opportunity that is probably something that most of your competitors doesn't have, right?
I think so.
Yeah. Before we went up here to see the print arch, you told me that you were working as a professor on an engineering school, right? I mean, one thing is that you teach about engineering, but when you're into like turning it into products, I mean, that must be, I don't know if it's difficult, because I know that's your skills, but it must be quite interesting, because this is something that you worked on for many years, and now it's here, right?
Yeah, it's for me, it's really fun to have the fundamental understanding in the physics, like the recirculation, right? We're moving the fluid through the printhead, and that is taking away heat that's building up in the printhead, right? So to understand how to design that flow to remove that heat, and then get to see it in a customer application is pretty cool.
And just for people again to understand, I mean, when you build this, there's a lot of things that is like invented from scratch, but you're still depending on that you have engineer colleagues that are able to do the print heads, right? Because that's an engineering exercise in itself as well, right?
Absolutely. Yeah.
Fantastic. Well,
sometime we'll have to get you to the printhead factory.
Oh yeah, I would love that. Unless it's so tiny and so secret that I can't see anything, right?
No. Yeah.
So that was the printing side of it.
So, yep, paper is going up underneath us. We're printing black, cyan, magenta, yellow, orange, and violet. One of the important factors at this width and at this speed is how do you support the paper while you're printing on it, right? With thermal inkjet, with water-based inks, you worry about the paper shape while you're printing. So underneath each print bar, we have a set of driven rollers. Okay. And these driven rollers help with tension control, they help with velocity control, they prevent slipping, and they really make sure that the paper is where it's supposed to be when we print on it. This is the type of knowledge and expertise that Koning & Bauer brings to this partnership.
Okay. And I was just thinking, because you mentioned the arch as the also a very important part of this of the paper pass to get it flat, but because you're working on many different substrates, maybe also a little bit thicker than you do in commercial print. Basically, you need that pressure in order to make sure that you get exactly what you said here, right?
Correct. And we have a feature that will allow you to adjust that separation distance based on the paper that you're running, right? So we call that the pen to paper spacing. And the press has a feature that will enable 2 different settings for 2 different thicknesses of paper.
And we spoke about it when we were in the box just before. That, of course, I mean, when you run the machine, this is not something that you need to service. That is not something. It's not a consumable. It is basically something that lasts for, like, let's say, years, right?
Yeah, right. I mean, our expectation is that this is a 7, 10, 15-year investment, right? And it's a manufacturing tool, and manufacturing tool needs maintenance, but manufacturing tools are designed to last the life of the product, right? And so that driven roller system actually reduces wear by making sure that we don't have drag and friction, and we think our testing has shown that it's improved the print quality and reliability.
At current time, you don't have much heat here, right?
Not much heat here.
Yeah. So basically, we have we spoke about the coating. So the coating prepares the paper. We have the paper now or the substrate being printed, and we have the pressure to make sure that we get even surfaces, just to give a few examples.
Tension, we call tension.
Tension, yeah, yep. That's, let me call it tension as well. I think I normally do, yeah. But now we get into something that is a little bit different, right? Because now we need to dry it.
Well, now we need to dry it. So we're going 1,000 feet a minute, and we've now put down 6 colors of ink, and we're gonna exit the top of this arch, and we're gonna go into 4 dryer boxes. This press uses infrared radiation and hot convective air to drive the drying process. So, right away we hit it with a strong dose of infrared radiation to heat up and to start the drying process immediately. We know that drying is a mass transfer process. You have to have lots of airflow to move that moisture away. Yeah. So these first 2 dryer boxes really do emphasize a lot of convective airflow as well as the radiation to provide the heat.
I think that sometimes customers looking at inkjet underestimate how difficult this actually is, right?
I think so too, yeah. I mean, HP and Koning & Bauer have invested a lot of time and energy in developing drying technologies for this inkjet space, right? And this is another area of our collaboration, right? They bring a lot of experience in the paper and in the dryer systems, and we bring, this understanding of our ink chemistry, so the dryers can really be developed for this ink, for this paper, for this application space.
So just to understand that basically means that when HP in your research lab start formulating the inks, you together with Koning & Bauer and your drying team start to speculate, okay, how little water can we add to the carrier and how fast can we remove it again when we get to here, right? That is how it is, right?
Yeah. So the drying process is one of the first contributors to the ink formulation, right? Those 2 things have to work in tandem to have a good product. And every press I've ever seen ends up being dryer limited eventually, right? The customers always want more ink and faster. So being intentional about that design is really important.
But I mean, and again, I know it's not comparable to the commercial space, but when you look at the 2200, you solve that by having different configurations of dryers, depending on what kind of applications you run. But here, you don't know in advance whether it's like full coverage or it's just a logo, right? So you need to be able to handle everything, basically.
You need to be able to handle everything. The dryer system is set up in a way that you could have kind of configured zones like the Advantage 2200. On our development vehicle, we've got all of it. We've got the belt and the suspenders.
So you're the lucky ones, that's what you're saying.
That's
right?
we're the lucky ones, yeah. So we're gonna come out of the dryer boxes and we're gonna keep moving down the paper path. And the next system we come to is our vision system. So inside this box, we have 3 high-speed line cameras that are taking pictures of the web, and we're stitching those images together in real time. We use that for color-to-color registration or alignment. We also use it to measure nozzle health, to measure printhead health. We've also developed features that can measure the density across the width of the web and make adjustments to improve the print uniformity.
So that is a pretty important part of it, right?
It's a pretty important part of it.
Yeah.
Yep. It's one of the things HP brought to this collaboration, and it really, again, it's using the same building blocks that we have in our commercial spaces on our T1100.
We're going to see the camera system, right?
Yeah, we can open this up.
Yeah. And I guess that this is a pretty important part of the machine, right?
It is. Yeah, it's pretty central to our print quality, right? And our ability to alert the operator when there's a nozzle health or quality problem. So what you're looking at are 3 high-speed line cameras that are going to take an image of the printed web, right? Then our vision system software stitches those images together. And we're using this primarily for color-to-color registration or alignment. We're using it to monitor nozzle health, and then we're also using it to measure and compensate for uniformity variation.
So does that mean that when a camera inspection system with 1,000 feet per minute takes photos of this, basically that can be used to alter the machine to compensate, or if there's any skews in the paper or anything like that, you can basically just from these cameras and control that mechanically, or? Yeah,
so we ask our customers to run a startup calibration to get that accurate measurement and to adjust the alignment. We adjust the data to make the drops land where we want them to. We do have some features that are pretty critical in the packaging space that where the vision system will continue to monitor that alignment throughout a run, and will make small corrections to make sure that the print quality at the start of roll 1 and the print quality at the end of roll 3 are the same.
Yeah. So the densities are, and the color, and because you also have the spectra.
We have a spectrophotometer. Spectrophotometer is used primarily in calibration and setup runs.
Okay. So that is not for like the color accuracy across the web, basically.
In a calibration run, right? It's not measuring. Today, it's not measuring during live printing.
No. And one thing I forgot to ask, so when you have like the cameras here, the high-speed cameras, you mentioned about some of the features, but does that mean that you can also say that what I see on the print is also aligned with what I have on my PDF, basically, or?
Yeah, so we do have some features that we've taken from our commercial space where we do a PDF compare. We do some validation that your name is on your bill. In the packaging space, because there's such variation in artwork and because the printing speeds are so much higher, we generally partner with other vendors, other suppliers to do that 100% inspection.
But I mean, as long as you have the cameras, you can basically do whatever software can do with the input afterwards, right?
Correct.
Yeah. We're standing here in a little bit narrow space, but we can move a little bit to the other side, right? Because basically on the other side, we again looking at a coating unit, but this is like the post coating.
This is the post coater, exactly. Yeah. So we're going to go underneath our feet and we're going to go up into this post coater.
Yeah.
This is applying an overprint varnish. The application here is packaging, it's boxes, and so the durability requirements are significant. Yeah. We also have customers who like to vary the look and feel of the printed content, right? Another thing that I kind of learned about late, but the coefficient of friction of the boards is important as you're stacking up these boxes. You want to make sure they don't slide and fall over, right? So all of that can be controlled by the coating fluid.
Even that kind of, let's say, slippy kind of surface.
Even the slipping surface.
Fantastic.
Yeah, so what we're looking at today is a flood coater from Koning & Bauer. However,
It could be any coater?
It could be any coater, right? Okay. Koning & Bauer makes sleeve coaters that allow you to do patterned overprint varnish. We also partner with Conprinta to do patterned varnishes.
Okay, so that is like, again, a little bit when we talk about the buying process, basically you start identifying a customer and talk about what kind of applications they need to be solved with this technology, and then you configure the machine accordingly, right?
Yep.
Yeah.
Yep, that's right.
The actual fluid that you have here in the coating, that's not the same as in the primer, right?
Nope.
Yeah.
The overprint varnish is commercially available from a whole host of suppliers, and again, our customers are going to pick that varnish based on the need of the application, right?
Yeah,
the varnish might have a different slip angle, it might have a different gloss, right?
And that basically also means, because I mean, the machine that we have walked through so far, now it basically is just in quotation, piece of paper that has been printed on, right? Now you can do whatever you would like to do with any kind of print, right?
Yep. You could do any type of finishing, right? But yeah, this is kind of where we start to go from like you said, printed paper into what does the application have to be?
Precisely, yeah.
Yep.
Fantastic. And this is again something where you, again, just to put it, basically you have this machine to make sure that the print quality and the slip and all the things is continuous throughout the rest of the processes, right?
Correct.
Yeah. Okay. Wow.
So apply the overprint varnish, and then like on the pre-coater, we're going to dry it
Again,
and we're going to come out.
that's what I'm saying. It's not a printer; it's a dryer.
So now we've primed the media, we've printed the media, we've varnished the media, and then we've also gone through some dryers.
Yeah.
One of the really important paper properties to make a good box, to make a good board, is the moisture content.
Yeah.
So the last kind of critical step in the quality of the print or of the product is to manage that moisture content.
So that just to get that clear. So that basically means that we have paper that has like got the, let's say, relative humidity to the room it operates from.
Correct.
But you put a lot of stress to the paper because of the heat, the 3 times heating processes. Now you basically want to get the relative humidity back to where it started.
Exactly.
Yeah.
Exactly.
And is that just applying some water to the sheet, or is it more complex than that?
It's a little more complex than that, right? The one of the nice things about being print on one side only is we can use the back side, so we're actually using a Wico moisturizer to add moisture to the back of the sheet. So it's mostly water. There's a little bit of surfactant in there, and since we don't have to worry so much about interacting with the rest of the print stack, we can get a little better efficiency of moisture transfer to the paper.
Okay, and do you get back to square zero or square one, or where? I mean, how far do you get from where you start?
The system is capable of getting back to where we started.
But it's not a dynamic. It's not a dynamic process, right? It's like it's a decision. You say that, okay, it does this and this, so you adjust it, or do you measure the starting point and the end point, or?
I would say our customers who are most concerned about quality will measure the starting and the end point, and they'll adjust their recipes to deliver that.
Okay.
Yep.
So that is possible, of course.
Absolutely.
Okay.
Absolutely. So now we've re-moisturized, and we're going to exit the press with a primer, with ink, with a varnish at equilibrium moisture content, and now our customers will roll that up. And we partner with a number of with Koning & Bauer and a number of other vendors to do the rewinding.
And that's also why we decided we're not talking too much about that part of it, because that is basically something that you use here for R&D in this particular configuration.
This is the R&D configuration, and that in that rewinding space, we're using industry standard hardware and systems.
Jason, when we look at the machine from here, how far is it?
I actually don't know.
Okay, so we have to ask a special.
We'll have to measure it out.
Okay, but it's a quite compact machine for doing what it does, right? But it's still at the same time very impressive to see, because it has that size to it.
It's a big printer, and as our friends at Koning & Bauer remind me, it's a small press.
Oh, yeah, they just put you on the right spot, right?
That's right.
Fantastic. Jason, wonderful to get to know you and,
Thank you.
your machine.
Yeah, appreciate it.
I'm pretty sure that, as I said to you many times during the walkthrough, that when you have worked on a machine for many years and now you see it in operation and getting into market, it must be quite certain feeling, right?
It feels pretty good. Yeah, it feels pretty good. It's nice to know that, it's nice to see the fruits of the labor. So.
Last question, and that has nothing to do so much with this machine, but you said that you have 5 of the 11 series in the market right now.
So we have 5 running the new generation of the printhead.
Okay,
Yep.
so you have more machines in the market. But I was just wondering, the feedback, I mean, because again, you were involved from the first machines were delivered, right? So how is the feedback? Because I mean, this is digital space in a corrugated world that has typically been flexo or offset or other printing technologies, rotogravure, things like that.
Yep.
What is the impression from people with this, that own these technologies today?
In general, our customers are super happy, right? It's a demanding application space, right? With demands on print quality, with demands on media breadth, with demands on durability. But at least 3 of our customers have more than one T-series packaging press.
Sounds like a good evidence, right?
That's a good indication that we have brought something to the market that enables our customers to be successful.
Fantastic. Great.
Thank you.
Sir.